created by MindSticks Foundation Trusts.
Hello and a very warm welcome to all of you. Today, we're going to explore the invisible factories living right on our dining tables. In this explainer, we'll journey from the basics of microbiology through dairy and probiotics into your pantry staples, and finally, we'll uncover the fascinating world of industrial enzymes and commercial additives. Let's dive right in, shall we?
Starting with Section 1, Introduction to Microbiology.
Now, to really appreciate the food we eat and the medicines we take, we need to understand the foundational science behind it all. We generally look at two distinct branches here. First, there's applied microbiology. This is where we study the enzymes, applied genetics, and molecular biology of microbes, purely focusing on how we can use this knowledge to benefit society. On the flip side, we have industrial microbiology. This is where we take that knowledge and scale it up. It's all about the commercial use of microbes, mostly using fermentation processes to create products that have huge economic and social value. Think about everything from the bread you eat to large-scale pollution control.
Moving right along to Section 2, Dairy, Yogurt, and Cheese. Let's look at some very familiar, edible examples.
You know, it's actually quite remarkable how ordinary, pasteurized milk gets transformed into delicious yogurt and cheese, and it's entirely thanks to helpful bacteria. Take yogurt, for example. We boil the milk, cool it down to a nice warm temperature, and then introduce bacterial strains like Streptococcus thermophilus and Lactobacillus delbrueckeri. So what happens next? Well, the bacteria get to work creating lactic acid, which coagulates the milk proteins. And that is exactly what gives yogurt its lovely, dense consistency and that characteristic slightly sour taste we all love.
Now, making cheese requires a bit more skill, and it happens on a massive scale all around the world. We always start with strictly cleaned and sterilized cow's milk. Then, we mix in those essential microbes and sometimes colors to impart that specific sourness and look. Next comes a very crucial step: removing the whey. That's the water content, and removing it gives the cheese its dense, celled texture. Finally, this solid mass is cut, washed, rubbed with salt, pressed, and stored away for ripening. And here is a truly wonderful fact for you. Traditionally, an enzyme called rennet, taken from the alimentary canal of cattle, was used for this. But today, to produce pure vegetarian cheese, we actually use a protease enzyme obtained from fungi. Isn't that brilliant?
This process brilliantly illustrates how the simple element of time completely transforms our food. Freshly prepared cheese is always quite soft. Think of your cottage cheese or mozzarella. But if you store and ripen it for 3 to 12 months, it transforms into semi-hard cheddar. Leave it for 12 to 18 months, you get that very hard, incredibly flavorful Parmesan cheese. It really is all about patience and giving those microbes time to do their magic.
Let's shift our focus now to Section 3, the power of probiotics. We're moving from basic dairy to functional foods.
You've definitely heard the buzzword probiotics. These are essentially milk products, but with a very special active addition. Listen to these scientific names carefully: Lactobacillus, Acidophilus, and Bifidobacterium bifidenum. When we consume these active bacterial colonies journey right into our alimentary canal and take on the essential job of maintaining the balance of our intestinal microorganisms. So, what's the big deal with these probiotics? Well, they're like little peacekeepers in your gut. They maintain balance by increasing the population of helpful microbes that aid our digestion. And at the same time, they actively decrease the population of harmful microbes, like Clostridium. Plus, you know when we take strong antibiotics and our useful microbes become inactive? Probiotics actually help wake them up and make them active again. They boost our overall resistance, lower the ill effects of harmful substances, and doctors even prescribe them nowadays for the treatment of diarrhea.
Coming up on Section 4, Bread, Vinegars, and Beverages. Time to step into the pantry.
We really owe our morning energy and our evening relaxation to specific microbial strains. To get our coffee, a microbe called Lactobacillus bravis is used to expertly separate the seed from the fruit of the coffee Arabica plant. A very similar separation process happens for cocoa seeds, but using Candida and Saccharomyces. And of course, for your wine and cider, the famous baker's yeast, Saccharomyces cerevisiae, is the star of the show, used for the fermentation of grape and apple juice.
The processing of these coffee and cocoa seeds relies almost entirely on fungi like Aspergillus oryzae. But, you know, it's not just our favorite beverages. Think about vinegar for a second. It's used globally to impart that sharp, sour taste to our pickles and chutneys.
Chemically speaking, commercial vinegar is simply 4% acetic acid. And how do we get it? By fermenting carbon compounds like fruit juices with yeast and then mixing it with specific bacterial strains like Acetobacter. Let's zoom out a bit for Section 5, the role of microbial enzymes in massive industries. In the old days, the chemical industry relied heavily on harsh chemical catalysts. The problem? They required extreme temperatures and pressures, which caused severe erosion to expensive instruments. But today, microscopic organisms are stepping in to replace these harsh chemical factories. We now use microbial enzymes. The absolute game changer here is that these enzymes are highly active at low temperatures, low pH, and low pressure. This saves an immense amount of energy. Furthermore, they don't create unnecessary byproducts, which means our purification costs are minimized. They are eco-friendly, completely reusable, and are now extensively used in major industries like leather, textiles, and paper.
And that brings us to our final stop, Section 6, Commercial Acids and Additives.
Now I have a quick question for you. When you treat yourself to a lovely, rich scoop of ice cream or drink a really thick milkshake, what exactly gives it that beautifully dense, thick consistency?
The answer might surprise you. It's xanthan gum. It's a specialized gum obtained by fermenting starch and molasses, all with the help of a microbe called Xanthomonas species. Because this gum is highly soluble in both hot and cold water and boasts a very high density, it acts as the secret ingredient that gives our ice creams and puddings their luxurious thickness. It truly is amazing how much we rely on the microscopic world for our everyday culinary delights.
Let's uncover a few more hidden ingredients produced by commercial organic acids. Take simple sugar molasses. Introduce the microbe Brevibacterium, and what do you get? L-glutamic acid. That's the key component in producing monosodium glutamate, which you probably know better as Ajinomoto, or consider the microbe Aspergillus niger. It processes sugar molasses to produce citric acid, giving that delightful zing to our cold drinks, toffees, and chocolates. Even the lactic acid that serves as a vital source of nitrogen and vitamins comes directly from Lactobacillus delbrueckii.
So, as we wrap up today's explainer, I want to leave you with this provocative thought to ponder. From your morning cup of tea or coffee, to the bread you toast, the cheese in your sandwich, right down to the thick ice cream you might have for dessert, can you find a single meal in your day that hasn't been touched by these invisible, microscopic factories? It seems we are deeply, permanently connected to these helpful microbes, isn't it? Thank you so much for paying such close attention today. Keep observing the science in your everyday life, and happy learning!